Welcome to Maths and Science by IITian channel. In NEET Physics and IIT JEE Physics, in the last class or in the last lecture, we have discussed about the moment of inertia tensor. How L is equal to I omega can be used. And we have discussed many things on moment of inertia tensor, and using that moment of inertia tensor, we have also discussed how to get the moment of inertia from moment of inertia tensor. Moment of inertia about a particular axis of rotation passing through a particular point. These things we have discussed in the last two classes on moment of inertia. Please view them for details. In this, I felt it's prudent for me to discuss little bit about the properties of the moment of inertia tensor, in which typical words are used like rotor. What is the meaning of a rotor? Being regularly used in engineering applications, and how a rotor is defined. We are not going into the design and formulating formulae, all those things. We will be defining with the help of moment of inertia tensor. If any question is asked on rotor, you should not get confused in the examination. These are all simple definitions but useful definitions. Like a asymmetric top. In a question, if it is given moment of inertia of a asymmetric top, they may not talk about the moment of inertia tensor. They may talk about moment of inertia of a asymmetric top. You should not get confused. For that, I brought these nomenclature in front of you. Then symmetric top, then spherical top. What are all these things? I want to make you familiar with these words. That is my ultimate aim. So that in the examination, anything pertaining to rigid body moment of inertia, if it is asked regarding rotor, means you should know what is a rotor. Otherwise, you cannot answer. If it is regarding symmetric top, means you should know what is symmetric top. Then only you will be able to answer the question or solve the problem given in the examination. This video is useful, lecture is useful for both NEET and JEE Physics and also CSIR Physics. And let's go one by one. Properties of a moment of inertia tensor. This is our topic. On this topic we will be discussing now. What is a moment of inertia tensor? That is equal to I is equal to Ixx, Ixy, Ixz, Iyx, Iyy, and Yzx, Yzy, Izz. This is called as the principal axis, principal diagonal. This is a symmetric matrix because Ixx is equal to, here we will define each and every term so that you will understand. Ixx is equal to, we will write it as sigma. In the last class I have explained everything. Please refer to last class on this subject. yi square plus zi square. Iyy is equal to sigma mi into xi square plus zi square. Izz is equal to sigma mi into xi square plus yi square. Now, what is Ixy? Because of the symmetry, Ixy and Iyx are same. Iyx is equal to minus sigma mi xi yi. This Ixy Iyx is over. Izx and Ixz are same. Izx and Ixz because of the symmetry minus sigma mi into xi zi. Then next is Izy and Iyz are same. Izy is equal to Iyz, that is equal to minus sigma mi yi zi. Now we have defined the components in the moment of inertia tensor. If Ixy is equal to Iyx is equal to Ixz is equal to Izx is equal to Iyz is equal to Izy is equal to 0. What happens? What happens to that matrix? I will be Ixx 0 0 0 Iyy 0 0 0 Izz. In this condition, these are all called, these can be represented as I1 0 0 0 I2 0 0 0 I3 I1 I2 I3 are principal moment of inertia. Principal moment of inertia, that is principal axis. Now, we have understood the definitions. Now, we will classify on the basis of these properties. That's what we classify. Classification. A rigid body, classification of rigid body. A rigid body is of a spherical top. A rigid body is of a spherical top. I am talking about spherical top. A rigid body is called as spherical top. Then Ixx is equal to Iyy is equal to Izz. Then it is called as spherical top. Otherwise, when all principal axes moment of inertia are same, then it is called as spherical top. I1 is equal to I2 is equal to I3. Examples are sphere, and cube. It's more, you just see, from the moment of inertia tensor, it is already symmetric. Ixy is equal to Iyx is equal to Ixy is equal to Iyx. Similarly, Ixz is equal to Izx. Due to that symmetry and also the principal axis being same, that implies the moment of inertia of this sphere about any axis passing through center is same. What is the conclusion? This is very, very important. It implies the moment of inertia of a sphere or cube is same about any axis passing through center of mass. For this only I have given 2 lectures on moment of inertia tensor, and how this has come, this is more important. Now I have explained. In JEE mains, in JEE advanced, a question can be asked for a sphere or for a cube, the moment of inertia about a particular axis passing through center of mass. They will give the axis also. They will give 2 axes passing through center of mass. They ask you to find out the moment of inertia behavior. Moment of inertia is same. Let the axis be different, but when it is passing through the center of the mass, then for sphere or cube which is symmetric, and when Ixx and Iyy and Izz are same, or I1, I2, I3 are same, then let moment of inertia be in respect of about any axis passing through center of mass is same. Please understand this. Here, if you draw a sphere, it's a sphere, let us say, it has got 3 axes. For a solid sphere, Ixx, Iyy, Izz are same, hence it is a spherical top. It is a spherical top symmetric top. These things are to be not only on the basis of the shape. Even cube is called as a spherical top. Let it be, this may be. Let us draw the cube. Let this be the center of mass. Let this be the center of mass here in sphere. Let this be the center of mass here in cube. It is, these both are examples of spherical top. Then, what about the symmetric top? Next one. In this sphere, let us say this top portion is removed. In the sense, like in earth, we have flat position at poles, flat at the poles, and little bulge at the equator. This type of structure is called symmetric top. In the symmetric top position, two axes are same, principal axis, I1 is equal to I2, but third is not equal to them. This is the definition for symmetric top. For this, we can take safely earth, we can take it as an example. One example. Second example can be a cylinder rotating about z. Ixx is equal to Iyy but not equal to Izz. This also we can say a type of symmetric top. Now, these shapes like where? Now next shape comes. Third shape is, we will call this as B because it is an example. Here we will call this as an example. Let's not get mixed up with the numbers. A, and one is spherical top. Second is symmetric top. Third is asymmetric top. These are different types of the rigid bodies. On the basis of moment of inertia tensor, they are defined. Asymmetric top. That there is no symmetry. Asymmetric top means there is no symmetry. A rigid body for which Ixx is not equal to Iyy is not equal to Izz. All the three moments of inertia are different in different axes. Then it is defined as asymmetric top. Any rigid body like a rock, any shape like this, any shape, any rigid body comes under the definition of asymmetric top. If Ixx is equal to Iyy and not equal to Izz, it is a symmetric top. Asymmetric top means all are different. Moment of inertia in all axes is different. Two axes is same and is not equal to third axis. That is called as symmetric top. And spherical top, in all the axes the moment of inertia is same. Please remember these three definitions. Now, next comes the most important engineering application is rotor. What is rotor? On the basis of moment of inertia tensor, how we define rotor? Just imagine we have defined spherical symmetry, spherical top symmetry, spherical top moment of inertia tensor, and also symmetric top, asymmetric top. Now we will define something called rotor. It's a very, very important part in the machinery, and rigid body motion is applicable. The most applicability of rigid body motion is in the rotors. Rotors are under motion. They are always under rotating motion. Rotating motion. Rotor. It is a rotor. Stator means opposite of rotor is stator. It is static. It is not under motion. DC-AC motors, generators, machines, there is a pump, there is a motor, shaft is there, here is the motor of capacity HP, DC or AC supply is given, this rotates. That means it is a rotor, rotating equipment. It's applicable in electromagnetism, rotating shafts, windings, rotating shafts. Examples: windings, electrical equipment. These are all the things which are useful every day and they can be asked. Some questions in IIT JEE mains are advanced. They will be asked on the practical physics. These are all part of the practical physics. Physics can never be always theory or read in the textbook. It's practice. You might have seen many rotating equipment in your house. All these come under rotor. Permanent magnets we can even call generators, permanent magnets. These are all examples of rotors. They are rotating. Something is rotating in this direction. Something is rotating in this direction. Some part is rotating, that is called as rotor. Now, with mechanical energy or electrical energy, rotor is called as is. In vector calculus, it is the curl of the vector field. Rotor is equal to curl of the vector field. That is equal to, curl means this one. For the time being, you please remember this much regarding rotor. And in the sense of, when I discuss about the electricity and magnetism and vector fields, they come over there, and Maxwell equations, at that time I will discuss in detail. In this context, we are defining rotor on the basis of moment of inertia tensor. On the basis of moment of inertia tensor, when you define rotor, that is defined as a rigid body for which a rigid body is there in which Ixx is equal to Iyy, but Izz is equal to 0. This is called as rotor. Very important. In two directions, the moment of inertia is same, but in the third direction, moment of inertia is 0. Then this is called as rotor. This has a lot of engineering applications. That means we have classified rigid body. In this lecture, we have classified different rigid bodies on the basis of moment of inertia tensor. Ixx is equal to Iyy is equal to Izz. Ixx is equal to Iyy is equal to Izz implies spherical top. That is the name given. Don't worry about this top, sphere and all. Even cube also has spherical top. Next, Ixx is equal to Iyy is equal to Iyy, but not equal to Izz. That implies symmetric top. Third, Ixx is equal to Iyy is equal to, Ixx is not equal to Iyy is not equal to Izz. That implies asymmetric top. all the three are different. Fourth, Ixx is equal to Iyy, but Izz is equal to 0. That implies rotor. Please remember these four definitions which I have explained you in detail, the concepts. Please remember these, and whenever any question comes in JEE Mains or JEE Advanced, if they say that there is a rotor, that means you can take it for granted that Izz is 0. Ixx is equal to Iyy. If they say that it's an asymmetric rigid body, then you can say that all the three directions Ixx is not equal to Iyy is not equal to Izz. If it is symmetric means Ixx is equal to Iyy, that is not equal to Izz, it is symmetric top. Then spherical top means a cube also comes under spherical top. Please see that. With this, I want to conclude this lecture with a note that rigid body, we have sufficient amount of lectures, defined the rigid body, then we have gone into moment of inertia calculations, we went to moment of inertia tensor, and we went to define the finding the different types of rigid bodies on the basis of moment of inertia tensor, and finding the moment of inertia and moment of inertia tensor differences. These are all the concepts. From next class in rigid body, what I will do, I will take up some questions from JEE Advanced, JEE Mains or NEET, NEET Physics, JEE Advanced, JEE Mains. Either we take directly from them or similar questions we try to solve using the concepts whatever we have learned till now. I want to just give a small homework to you to brush up your knowledge. What is the moment of inertia? About the tangent to a circle. Instead of a circle, we call it as a disk. Because this type of question, on the basis of this concept, there is a question asked in NEET. Please try to answer this. You know, for a disk, the moment of inertia about an axis perpendicular to its plane and passing through center is half mr square. Then moment of inertia about a tangent, let this be radius r. You please find out about the tangent. The answer should be, try to get the answer about the tangent. About the tangent, it is the tangent 5 by 4 mr square. Please try to get this answer. This is the answer. Let us discuss this type of practical problems from next class onwards at the level of NEET Physics, JEE Advanced and JEE Mains Physics. So that this type of problems once we practice, then we will be able to answer the questions correctly in the examination. I want to close this lecture now, and best of luck to everybody. Thank you for listening to me. If you feel there is a value addition to you because of this lecture and because of my channel, please share the details to the others known and subscribe to my channel. Maths and Science by IITian.